anything from anything. Remember, you are muted.
Will we have any implicit differentiation
Yes,
questions?
yes.
Okay, I'm gonna paste a copy.
Sure. Sure. Caleb, you were first. I thought you wanted something, or you want us to choose, or?
Yeah, I was just looking through the WebAssign and the book as well.
Okay.
I was thinking maybe just choose like any optimization problem, one that we maybe haven't looked at yet.
Okay. I think we looked at all types that are potential candidates. So I may choose a problem that was already done in class.
Okay.
I don't
look through one for the book to say, or through WebAssign.
I don't remember what we did exactly. So we did the poster problem. We did the piece of wire problem. You want the problem in which the function is given or the function is not given?
I prefer one that is not given. I think I found one on WebAssign.
Okay.
I think number 13, but that one you would have to pull up WebAssign because it's pretty lengthy in its prompt.
So this, we're talking about section 4.7, and you said number 13?
Yes.
Okay. Uh, 3.7. I'm sorry, 4.7. Okay. Okay, so a fence 8 feet tall, we see that. And this is the ladder, I see. Okay. So we have here 4 feet. We have here 8 feet. Okay. Runs parallel to a tall building at a distance of 4 feet from the building. Okay. What is the length in feet of the shortest ladder? So I'm going to call this W. So I have to find the minimum of W. So that's the question. And it has to be in feet, of course. That will reach from the ground over the fence to the wall of the building. Okay, round your answer to 2 decimal places. Okay, good. So in order to determine the minimum of a function, I have to have the function. And the function has to be, or has to depend of only one variable. Okay. So let's see what we can do here. We have to label these things. So I'm going to label this as y. I'm going to label this as x. And this is our w. And this is 8, and this is 4. Now, the first thing I see is 2 triangles, this triangle and this triangle. And they are both right triangles, and they are similar. Similar triangles. Why they're similar is because they have the same angle here. They have the same angle here, a right angle. And obviously, because the sum of the angles in any triangle has to be 180, this is exactly the same with this. It has to be. If these two are the same, and this is the acute angle in both of them, then these two have to equal each other. So I have to show that that the 2 triangles are similar, and then I can write proportions with their sides. And I have to be very careful how I write the proportions, because all the top sides have to come from the same triangle. All the bottom sides have to come from the same triangle. but it's a particular order that I have to impose. So I'll start with this angle. The opposite leg of this is 8, the opposite in the small triangle. So I have the small triangle at the top and the big triangle in the denominator. So the opposite of this is 8. The opposite of the same angle in the big triangle is y. So I already have 8 over y. Now this, I start again with a small triangle. The opposite of this is x. The opposite of this, of the same angle in the big triangle, is x plus 4. Finally, I am looking at the right angle. The opposite is this. I don't have a letter for this, so I'm going to invent one. So this piece is going to be A. So this, the opposite side of this angle is A, and the opposite of the same angle in the big triangle is W. Okay. Obviously, I have a lot of unknowns here. I have y, I have x, and I have a, and I have w. Way too many, but w is my function. But I have 1, 2, 3 variables. So something has to go away. Okay, that's one equation. The second equation, I can write it from the small triangle as the Pythagorean theorem. A squared equals 8 squared plus x squared. So 8 squared equals 64 plus x squared. The same thing from the big triangle. So w squared equals y squared plus x plus 4 squared. Okay, so now I don't have anything else to come up with. So I can only use the similar triangles proportions. I can use the Pythagorean theorem in the small triangle and Pythagorean theorem in the second triangle, in the big triangle, small and big. So at this point, I have to manipulate, muscle all these equations and get an expression of W only of only one variable. So that's all I have to do at this point. This is just algebra. I have to muscle these equations into one. So I have this here with W. Let's see what I can come up with from here. So W will be AY over... Oh my goodness, yes, I touched, thank you. Sorry, I touched the cord or something. I moved the book. That's what I did because it was in my way here. Okay. So I'm trying to debate, I'm debating with myself. I'm trying to find the easier way of removing all variables but one. Okay, so I'm going to use this proportion and solve for y. So I have xy equals 8 times x plus 4. So from here I have that y equals 8x plus 4 over x. I'm going to replace this in here. So I have w squared equals this squared, which is 64, x plus 4 squared over x squared plus x plus 4 squared. Okay, at this point, I will have to take the square root and differentiate afterwards. Take the square root from both sides and differentiate with respect to x, of course, and see what happens. Okay, I'm on page 2. So w squared. Let me see if I can simplify this a little bit. I don't think so. I could factor out x plus 4, and then I have 64 over x squared plus 1. So I pulled out an x plus 4 squared, So then I have 64 over x squared plus 1. Okay, let's see what happens next. I don't know if this is going to be easier when I take the square root or the first one. But anyway, so w equals, we take the square root, it's x plus 4 times the square root of 64 over x squared plus 1. And now I can say that this is indeed a function of x. So I want to differentiate. First function prime is 1 times the second one, plus the first function times the second one prime. 1 over 2, the square root of 64 over x squared plus 1, now careful, times the inner function prime. So I'm going to write on the side 64x to negative 2 plus 1. This is what I need to differentiate. The inner function prime. One more time. The first function prime is 1, so times this, plus the first function times this one prime, which is 1 over 2, the square root. But I have to differentiate the inner function prime. So I have negative 124x to negative 3. So bring down negative 2 and subtract 1 from the power, and this prime is 1. 1 prime is 0. So that's it for now. Okay. I will simplify 2 and get here 64. I will find the least common denominator to be the square root of 64 over x squared plus 1. I need to multiply these two because this one needs a square root of 64 over x squared plus 1. So then I have 64 over x squared plus 1. And let's see what is left here. Plus, I have a negative 64x to negative 3. So I have an x plus 4 and times negative 64 over x to the third. Okay. So let's see how I continue here. I have a 64 over x squared plus 1. I distribute this to 1x, and I will have negative 64 over x squared. And now I distribute this to the 4. I think I have 256 over x to the third. Okay, let's recap one more second. So let's make sure that we're on the right track here, and then we'll continue. Of course, these two go away, and that's nice. Okay. So I got an expression for w squared. Stop me if you have any questions at any point in time, please. So once we get to this, I removed y from here. I solved for y. So I had 8x plus 4 and x times y. And then I solved for y to replace it in here, but I had to square it. 64x plus 4 squared over x squared. Now, I realized that I can pull out this x plus 4 squared, and I did. And then I was left with 64 over x squared but plus 1, because there is a 1 in here. Then I took the square root, and I got this times this. Now I'm ready to differentiate w prime, or get w prime. First function prime is 1 times the second one plus the first times the second one prime, which is 1 over 2 the square root, times the inner function prime, negative 128 times x to negative 2 minus 1. I simplified the 2, and I got negative 64x to negative 3 here. I have to find the least common denominator, which happens to be this. It's only one denominator, but when I multiply these two, I get this. And then plus x plus 4. And this piece is negative 64 over x cubed. Now, I copy these two terms, and I distribute negative 64 over x cubed to x. I get negative x 64 over x squared. Then I distribute negative 64 over x cubed to positive 4. 4 times 4 is 16. 6 times 4 is 24, plus 1 is 25. These two go away. Now I have x to the third minus 256 over x to the third and over this. So 64 over x squared plus 1. These are extensive algebraic calculations. Extensive. Finally, I want critical numbers. This cannot be 0, x cannot be 0, this quantity cannot be 0. It's a sum of two terms, it can never be 0. So only this can be 0. I'm saying, of course, when we solve a rational function z equal to 0, this, I just was discussing the fact that we are all safe in here. But when a fraction is 0, only when the numerator is 0, so x is the cube root of 256. Okay, but this is not what we are looking for, right? We are looking for the minimum length. So I only found x. And I didn't show that it's a minimum yet. So when you take the square root of 256, you will get, of course, 16. So number 3, okay? So x equals 16. And this is in feet. So that's our x. So I'm going to copy the figure here so I don't go back to it all the time. So this was 4. And this
Professor,
was, yes?
it was the cube root of 256.
Oh, I took the square root. Oh, no. Thank you. So 256, thank you. 1 divided by 3. 6 point, and they said 2 decimal places. Okay, so x equals 6.35 feet. Thank you so much. Okay, so this is 6.35 approximately. Thank you, thank you. At least somebody is watching. Thank you. Thank you very much. Okay, 6.35. Okay, perfect. So I have x, I have 0, I have 6.35, I have w prime of x. I have to study the sign because I don't know if this gives a max or a minimum. I have no idea. So this is positive, this will be positive. When I plug in 0, this is negative. So I know for sure that this is the minimum. In this case, also absolute. And relative. Good. How do I find it? Now I put 6.35 in the function. Like 5 pages ago. 3 pages ago, I'm kidding. Here it is. So in this function, I have to put in the graphing calculator and find W of 6.35. I have the calculator up somewhere. Yes. Good. Okay, in y equals, we want to plug in x plus 4, close, the square root of 64 over x squared, and close. No, I didn't really need to do that. Plus 1 and then close. Okay, so in here, just to be super close, I am going to put in 256 to power 1/3. I don't want to put the approximation. I want the calculator to do approximate only once. Okay, so I don't want to put the 6.35, but the exact. And when I press enter, I will get the length of the ladder, the minimum length of the ladder that will reach over the wall or the fence, sorry, will reach over the fence and touch the wall. And this is the minimum possible ladder that will do that. 16.65. So this is 16.65 feet. So we showed that it's a minimum. You have to show that it's a minimum. You cannot conclude, oh, 6.35 will give me a minimum. No. You have to show why using the concepts we learned in this class. Thank you for choosing that problem. As I said, it had extensive calculations, algebraic calculations.